All right, 7.4, reviewing trig identities. Normally what I do call this is I call this 7.0. The reason why is we want to really review the trig identities before we go into the different other identities that you're going to learn in this particular unit. So we're going to review the identities you learned in grade 11. The first identity is called the Pythagorean identity. You learned this identity and it was called sine squared theta plus cos squared theta is equal to 1. Now keep in mind it's not always a theta. Sometimes you'll have an x. For example, sine squared x plus cos squared x is equal to 1. Be cognizant though that if the question involves x's and you prefer theta, please make sure you write let theta equal x or let x equal theta if you're going to convert it the other way around. The reason I want you to do that is just in case you're given in university, you're going to be told a certain variable. If you change the variable, you have to state that you changed the variable. All right, now, sine squared theta plus cos squared theta equals 1 can be manipulated to give you, for example, if I take and I want to find cos squared, the value of cos squared, that is equal to 1 minus sine squared. And I can do the same for sine squared theta, and that will equal 1 minus cos squared theta. Now, there are different versions of the Pythagorean identity. Those include different identities, such as, and let's look at it. If we look at sine squared theta plus cos squared theta equals 1, so let's erase everything and start with the regular traditional trig identity. What you're going to do is you can manipulate this identity to be any identity you want it to be. So, an example is if you end up with, let's say, a secant squared in a question, okay? Secant squared. Let's say you ended up with secant squared. What is secant squared? Well, secant squared is the same as, and let's write this out, secant squared is the same as 1 over cos squared. So, 1 over cos squared theta is going to equal secant squared theta, right? Well, if I divide this side by cos squared, I can divide each of these by cos squared. And so this creates the other identities. To be honest, you're never going to have to use these other identities because you can manipulate all identities to be in terms of sine and cosine, and therefore you will never have to work with these other special identities. But I'm just going to show you where they come from. So you have 1 over cos squared, that is equal to secant squared. Cos squared over cos squared is equal to 1. And sine squared over cos squared is going to equal tan squared. And where that came from, that particular identity, is that's the next identity we're going to examine. So, here's another example of a different identity that comes from the Pythagorean identity that is derived originally from the original Pythagorean identity. And that would be, folks, that would be the same as this one. All right? So, this is the original identities that we have. Those other ones that I showed you have all to do with the different types of identities that can be derived from this original Pythagorean identity. Let's move on forwards. All right, reciprocal identity. Reciprocal identity is the same as, so we talked about earlier what cosecant was. Cosecant is 1 over sine theta. Secant is 1 over cos theta. And cotangent is 1 over tan theta. Now, remember that we're going to look at the QI identity, which is the quotient identity. Quotient identity implies that tan is equal to sine over cos. That's what you learned last year. Well, cotangent then is going to be the flip of the tan, which is cos over sine. So we use the reciprocal identity and the quotient identity for cotangent theta when we're converting in terms of sine and cos. On that note, let's look at the quotient identity. The quotient identity is tan theta is equal to sine theta over cos theta. There are many different versions that can be manipulated to use the quotient identity. The way I want you to understand it is that if you express everything in terms of sine and cos, you pretty much can solve any identity given by knowing the PI, QI, RI, and a couple of others that you're going to be introduced in this unit. Let's look at an example. Prove each identity, and then you have to state any restrictions on the variables if necessary. Now, in this course, I'm not going to worry so much about stating the restrictions. Okay, but let's look at an example of this case. Let's look at this example. The restriction is going to be placed obviously on the bottom. So the restriction, you would just write 1 plus tan squared x cannot equal 0. So we know that the denominator cannot equal 0. Okay? Or tan squared x cannot equal -1 if you're talking about simplifying that restriction. I'm not going to worry about the restriction. I'm not going to ask for it. To be honest, this part right here is going to be redundant because what I'm looking for is going to be what identity you use to be able to solve it. So for example, tan squared over 1 plus tan squared, okay, is the more complicated side. The other side just has a sine squared x. So you should be able to manipulate it. So we manipulate this tan squared over 1 plus tan squared x. How do we manipulate it? Well, automatically, you should see that this has a tan. Both sides have a tan, both the top and bottom. So what you want to do is express everything in terms of sine and cos. Tan squared is equal to sine squared over cos squared. That's the first part. Now, divided by the denominator. Because we're going to have a fraction over a fraction, folks, we want to make it a fraction divided by a fraction. Why do we want to do that? Is because we know for division of fractions that there is a rule for that. So, looking over here, this is the denominator, 1 plus sine squared over cos squared. We use QI, which is the quotient identity, to get this. And notice we have a whole number plus a fraction. Automatically, your instinct should be to get a common denominator. And that's exactly what should be done. So, we set it up as 1 sine squared over cos squared is divided by cos squared x plus sine squared x over cos squared x. Now, here comes the question. Do you see what I see? Looking here. Hopefully, you see what I see and see that this is an identity in itself. So let's convert this identity, multiplication, and flip. So we're going to do the following. Ready? Sine squared x over cos squared x times, now flip it over using pi, that it's cos squared x over 1. Remember that cos squared x plus sine squared x is 1. So when we flip it, oh, look at this, folks. The top here will cancel with the bottom here. So what will we get? Well, we will get sine squared x is equal to the right side. And why is it equal? So this answer will be sine squared x. And if you look on the right side, sine squared, it equals sine squared x. So that's the right side. So what we found is that left side equals right side. And we've checked that they are equal. And that obviously makes us happy, folks. All right, let's move forwards. Next one. We're going to look at this particular function. And this particular one right here, if you look at the question, it says, this is just the homework that was assigned. Which equations are not identities? Justify your answers. So question number 3 is not an identity, but the rest are. What I recommend you do is try and solve these identities. These are simple identities, and later on in the course you'll be given a handout with much more complex identities. All right, folks, let's move on. Now, looking at one of the examples, so we're going to look at one of the examples over here. What we have here is sine x plus, okay, so here it is. Let's solve this one. All right, so sine x over 1 plus cos x is equal to cosecant x minus cotangent x. So we have to manipulate one side or the other side. Which side do you want to touch? Hopefully that you notice that you want to touch this side, being the right side, and you want to touch that so that we could simplify. Cosecant x is 1 over sine x minus cotangent x, which is cos x over sine x. What did we use to get these answers? Well, we used RI and we used QI. We used RI, reciprocal identity, to get this value, and cotangent we know is 1 over tan, but then tan is also, we can convert it to QI. Why did we do this? Because we want everything in terms of sine and cos especially since the other side has everything in terms of sine and cos. So we do that. Common denominator, it's going to be 1 minus cos x over sine x. Now, looking on the other side. What's going on over here? We have the sine x on top and 1 plus cos x on the bottom. So what can we do so that we get this answer? Well, we can force ourselves to have a sine x at the top or 1 plus cos x on the bottom. All right? So why don't we try and force it to have 1 plus cos x? Let's do that. All right, so let's go back again. So this time what I'm going to do is I'm going to force, see how the numerator has a sine x, but our numerator does not have a sine x. So I can force my numerator to have a sine x. So essentially what I'm doing is multiplying by a magic 1. That 1 has the same top and bottom to make a 1, but instead of making it a 1, what I'm going to do is use it to be able to get the answers that I'm looking for here. Now, remember that I want this sine x here, so I do not want to cancel it with this. What I want to do is multiply the bottom by sine x. So I have 1 minus cos x times sine x because I want that sine x because that sine x is here. And the bottom, I'm going to get sine 1 minus cos squared x. Why is that? Well, the bottoms I multiply to get sine squared x. We know that sine squared x is equal to 1 minus cos squared x from pi. Well, how does that help us? Well, the bottom is a difference of squares. We can actually factor the bottom so that we will get 1 minus cos x times sine x, and on the bottom, 1 minus cos x times 1 plus cos x. Well, do you see what I see? Hopefully, you see that these two can be canceled. When I cancel these two, I will be left with just sine x over 1 plus cos x. And guess what, folks? Left side equals the right side. That makes us happy. And for restrictions, you just say that the denominator cannot equal -1. For the bottom over here, the restriction on the bottom here, restriction here is that sine x cannot equal 0. So again, the restrictions tend to really eat up a lot of your time. I am not looking for restrictions on your test. Let's move forwards. Sine x over 1 plus cos x. So the same question, but I'm going to show you a different way to solve it. So we convert it just like we did before. But what we do differently here, folks, is that instead of multiplying by the magic 1 of the numerator of the other side, I multiply by magic 1 with the denominator of the other side. So that forces us to have 1 plus cos x in the denominator. That will give us 1 minus cos squared x on the top. On the bottom, you get sine x times 1 plus cos x. You know that 1 minus cos squared x is sine squared x because of pi. And the bottom, you'll have sine x times 1 plus cos x. Because remember, we want that 1 plus cos x, so we want to get rid of the sine x so that we only have 1 plus cos x on the bottom. So look at this. These guys cancel. You have 2 sines on the top, 1 sine on the bottom, and they cancel to give us the values. All right, that's the end of the video, folks. Have a great night. Take care.